Let's see. Boyles law, named after Robert Boyle, one of the first people to come up with a quantitative law. Okay? So, and he did pressure and volume. Okay? And at constant temperature, there should be a comma there. Mrs. Drager, my 6th grade teacher, would be really upset. I don't put a comma separating my clause. At constant temperature, pressure and volume are inversely related. Inversely related means one goes up, the other one goes down. You saw that in a graph, right? And hopefully you figured out that you were supposed to multiply P and V to get K. Because P times V equals K. And this is what gives you inverse, because if this one gets bigger, if I'm going to multiply and get the same answer, this one's got to get smaller. See how that shows the inverse relationship? The only way I can get a constant, if as this gets bigger, that one gets smaller. Okay? But the way they act, nobody actually figures out K, because K is only good for that temperature and that amount of gas. Those are the two things they kept constant. So the way they use it is this. P1 V1 equals P2 V2. And that's true because P1 times V1 has got to equal K, and P2 times V2 has got to equal K, so K has to equal K. Dot, dot, dot. Okay. So in words, inversely related. In ideas, one goes up, the other one goes down. In math, P1 V1 equals P2 V2. In a graph, what did the graph of this one look like? It was a curve, right? Because twice the volume, half the pressure. 4 times the volume, I'm going to go the same distance, but I'm going to go a quarter down. Does that make sense? So that's how you get that curve. But if you take 1 over V versus P, you get a straight line. So see how they call that inversely related? Because the way I get a straight line is to inverse one of them. Directly related, I get a straight line without inversing one. So that's a good way of doing it. Okay, so there we go. That's the complicated math we're going to do here. And the complicated ideas. Not too bad. Okay, so, this would be example number 3 on your blue piece of paper. Remember, blue piece of paper had all the examples on it? So, example number 3. Yeah, you didn't get one? Oh. Yeah, this was the I don't want you to have to copy everything. So let's look at what they gave us. They gave me 25 liters of air. That's a volume. 1.0 atmospheres. That's a pressure. If the new pressure is changed to 1.5 atmospheres, that's a second pressure, so that must have been the first one over there. And the volume, the 25 liters was when it was 1 atmosphere, so that makes it V1. What is the new volume? They're looking for V2. This one's going to be easier to solve because there's nothing on the bottom. Charles' law was tough because there was something on the bottom, and sometimes you had to solve for the bottom one. Here, everything's up top to start with. So I want V2, so I need to divide both sides by P2. So V2 equals P1 V1 over P2, which is 1.0 atmosphere times 25 liters divided by 1.5 atmospheres. My atmospheres cancel out and leave me with liters, which is good because I was looking for a volume. And 1 times 25 divided by 1.5 is 16.66666, which with 2 sig figs is 17. Now, does that answer make sense? The pressure went up, so the volume should go down. The pressure didn't even double, so the volume won't even be cut in half. So it tells me the right direction and about the right size. See, I can check those really quick in your head. I do need you to take the time to write the numbers and the units in here, because the units cancel out, give you the right ones, because sometimes I'll give you the pressure in kPa and the second pressure in atmospheres. They won't cancel out if I do that. So make sure you write those units in. Okay. Example number 4. A balloon's filled with 73 liters of air at 1.3 atmosphere. It's a pretty big balloon. What pressure is needed to change it to 43 liters? So 73 liters is a volume. 1.3 atmospheres is a pressure. 43 liters is a second volume, so that must have been my first volume. And the 1.3 atmospheres went with the 73 liters, so it was a P1. And they want, what is the pressure? They're looking for P2. Do we know of an equation that has those 4 pieces in it? Because now we're on our second equation, so now we get to choose. I want the one with pressure and volume. That would be P1, B1 equals P2, B2. I want to solve for P2, which means I had to divide by V2. So P2 equals P1, V1 over V2 equals P1 was 1.3 atmospheres. V1 was 73 liters. P2 was 43 liters. That one I can't do in my head. So 1.3 times 73 divided by 43 equals 2.21. And my units, well, liters cancel out, and I'm left with atmospheres, which is good because I was looking for a pressure. Did it change the right way? The volume went down. So the way I make the volume of the gas go down is I squeeze it. I increase the pressure. And, oh, I got too many sig figs, don't I? 2.2. And did it change about the right amount? Well, I didn't quite cut it in half, the pressure, so I didn't quite double. Or it didn't quite cut in half the volume, so I didn't quite double the pressure. Make sense? So I made the right direction, about the right ballpark. So there's a quick check built in. That's what I've got for today. That'll let you do all that homework. Okay? So what I need you to do